Welcome, everyone. My talk is AssertTrue, isDecoupled, my tests. I'm Dave Liddament. Hopefully, you're all expecting this. So the one-liner for this talk, I believe that decoupled tests reduce the overall development and maintenance costs of a test suite. And hopefully, by the end of this talk, you'll agree with that statement too, and you'll have some ideas about how you might be able to reduce the coupling between your test code and the software you're testing. And the reason this is important is because the value of tests is determined by the cost of the bugs that are found by the test or prevented by the tests, minus the cost of the test suite itself. So we know that bugs have cost associated with it, and test suites also have cost associated too, both in the writing and the ongoing maintenance of them. So if we can reduce the cost of the test suite, we increase the value of our entire test suite. So I'm just going to make sure this is, there's a great talk going on in the main room next door. I just want to make sure you're definitely in the right place. This talk is potentially for you if you've done some kind of automated testing. If you've not done any testing, maybe it won't make that much sense. And also if you're interested in like high-level concepts that you can apply generally to the top of the testing pyramid. So we're talking about end-to-end tests and integration tests predominantly. We're not really talking about unit tests here today. So if that's of interest, please stay. If you're an experienced tester, or you've already got a great test suite, or you don't like abstract talks, then I'd sneak off now. You've been warned. Okay, I'm going to start with a confession. I was working on a project. It had lots of tests. That's not the confession. But I was near a deadline, and I had to update the code. I made a tiny little update to the code, and suddenly the test broke. And my confession is, I kind of looked at why those tests had failed and realized that actually the issue, I was 99% sure the issue was not with the code, it was with my tests. So my confession is, and I'm ashamed by this, I ignored the tests, so PHP unit wouldn't run them. But that's okay, because I knew I was going to come back tomorrow or the next day and fix them all, and it would be great. Now, I've got another confession, which again, I'm not happy about. 6 months later, some of those ignored tests were still ignored. And I have another confession. A year later, some of these tests were still ignored. And I'm going to stop with the confessions because you'll wonder what on earth I'm doing up here, really. And this is clearly bad. We have tests there that are there to protect us. So one day in the future, I might make a change to the code, or someone who's working with me might make a change to the code that would have been caught by those tests. But because those tests were ignored, we've lost that safety net, and we will reintroduce bugs and issues and regressions in the future. So I've been in the software industry for maybe about 17, 18 years, and I've been spending the last 10 years working on projects with some kind of automated testing with varying degrees of success. And I'm going to talk you through 3 stories where I didn't do things particularly well and the lessons I learnt in the hope that other people have a smoother progression than I did. But before we go into these stories, I'm just going to do a quick look at terminology. So when I talk about coupling, what do I mean? Coupling is the degree in which two objects, in which one object knows about the other's object's internal workings. So if we have 2 objects, A and B, and they're not connected, then there's no coupling at all. But in software, we need to have some coupling for the objects to interact together. So suppose A is an application and B on this diagram is an email gateway. Our ideal situation is if the application wants to send an email, it just says, send email, this is a message, this is the email address I want you to send the email to. And that's quite low coupling, which is good. But imagine if we hadn't architected the code particularly well, and the application needs to know about some internal workings of the email gateway, like maybe its credentials, maybe the transport mechanism, something like that, something that the application shouldn't really know. This is bad, because if we wanted to change our email gateway to another implementation, we might also have to update the code in the application. And if there's coupling between that and A, then a change over here could ripple throughout the entire system, which is something we don't want to have to do. So the lower the coupling, generally the better for software. I'm going to talk about test doubles. So a test double is something that looks the same as a real implementation, but it isn't. So imagine we're running tests, and we don't really want to send emails. Instead, we're going to replace the email gateway with a test double, maybe an email gateway spy. And what that does is we can then use our tests to see what emails would have been sent, but we're not actually sending emails for real. So a test double looks to the application just like a real email gateway, except it isn't. And then finally, the test pyramid. We've probably seen things like this. It's kind of the recommendation in the how much testing we should do. So we should predominantly, our test suite should be unit tests. Then we've got fewer integration tests. And at the top, testing end-to-end or user interface, we don't have many at all. And when I say UI, I'm not meaning we're testing the user interface. I mean we're testing our application via the user interface. So you might be testing elements of the UI using unit tests. But what I'm talking about today is using the user interface as our main entry point for testing our application. Tests are quick to write, fast to execute, they're quite cheap, and as you go up through the test pyramid, the cost of writing and running and maintaining the tests increases. So my first story, this is about an application where people were members of teams and they completed multiple choice quizzes, and at the end of the quiz they were told how many points they got, and also whatever team they were in at that time also got their points as well, and people could move between teams, but the points were associated with the team they were in when they took the quiz. And it was kind of all a bit of fun. New quizzes got released every so often, and there were prizes for the individual and the team who had the best engagement and the best score. So a relatively simple system. A typical user journey might be something like this. Bob signs in, he logs in, he finds a list of quizzes he's yet to do, he goes and does the quiz, he completes the quiz, he gets his score, and then his team's score also gets updated as well. So when we started on this project, we had no automated tests at all, and everything was done manually, and it became more and more painful to run all these manual tests, so we had to start automating them. And initially, we did all the automation of the tests. This is quite a while ago. We were using Selenium and using the user interface to test the business requirements of our tool. So once we automated it, it was better than having to do it manually, but things weren't great. Now, you might say, if we're talking about decoupling our tests from the software under test, maybe testing by the user interface is the best possible way of doing it, because we could throw away all our code, and we could replace it with something written in a completely different language. And if the tests all pass and there's good coverage, we could probably say, well, our tests, our new application is doing what the old application did. However, with testing like software, there's all kinds of compromises that have to be made, as we'll discover. So initially, our test looked something like this. There were loads of steps. There'd be something like, you're going to go to the login page, then you find the login link, then you click the login link, and then you find the username thing, and so on and so on and so forth. And it's not a very good test. There's lots of issues with this test, mainly because there's so many steps, and you don't really know what those tests are doing. It's not clear reading it. Also, the tests are incredibly fragile. What happens if, for example, we change the ID of the username field? Suddenly all our tests could break, and we might get reasonable requests. I want you to make this tiny little change. Can we just change the layout of something? Can we just change a button here? And suddenly we go from something where all our tests pass to half our tests fail. And this comes kind of back to what I was talking about in the confession. I could see that from a business perspective, we hadn't really changed anything. We just made a minor tweak to something in the HTML, and suddenly all our tests have failed, or a lot of them have failed. So that's why you kind of end up in that situation I was in. So testing via the user interface is good that we've completely decoupled ourselves from our implementation, but bad because we probably coupled ourselves to what is the least stable part of a software project. And the main problem is our tests, these are business tests that are testing like the business use cases, are too tightly coupled to implementation detail, like IDs of fields on a form, or the order in which you go from one page to the next. So, like all things in software, everyone else has experienced problems similar, and people far cleverer than me have worked out solutions to these problems. One way of solving this problem is to use a pattern called the page object pattern. So what we do is, instead of our test talking directly to our software under test, we have this intermediate object called a page object, and the page object wraps either HTML page or bits of a HTML page, and it gives it an application-specific API. So our tests are talking in the context, I want you to log in with this username and password, or I want you to answer this question. That's how the test talks to the page object. And the page object talks to software under test in terms of things like I'm finding an element on a bit of HTML, and I'm clicking a link, or I'm filling in some data. So objects can kind of interact in the same way a human can interact with a website. They could populate bits of data in a form. They might grab data off a page, like what was this person's score, and they might navigate from one section of the website to another. So this kind of reduces our coupling between our tests and our software under test, because if we go and make a change to our software under test, like renaming a field, we've just got to go and change the bit in the page object that tries to talk to that field. So we've just got to make one change. And we're isolating changes to software under test from our test case. So the reason this is beneficial is because, in reality, it won't just be a single test that's trying to do this. There'll be lots of tests. There'll be lots of tests all using the same page object. So whereas before, a single change to our software under test might have broken all 3 tests. In this case, we just update the page object once, and all of our 3 tests are still working. So our tests are kind of looking a bit more like this. We get our login page object, and then on our login page object, we say, I want you to log in with these credentials. Then I expect to be returned a quizzes page, and then I can interact with that, and so on and so forth. So this is better than we had before. However, the kind of questions I'm really trying to answer is, does an individual score get correctly allocated to their team? And even the test we now have, it's still not really clear that that's what they're doing. And we're still not immune to issues where changes might happen. So what happens if somebody says, could we change the page a user goes to after they've logged in? If we look at our original test, we see that on the second line, we're expecting that after login, we're going to a page which lists all the quizzes. But if that's no longer the case, then this test will fail, even though the business logic rules haven't really changed. So again, we're in a situation where a simple change has caused lots of failing tests. So a way around this is we could have another layer between our tests and the page object, I've called it the domain-specific language layer. And this provides an interface between our tests, which are talking kind of in the language of whatever business requirements we're trying to solve, and the page objects. And this means, so we're saying things like, I want you to submit users' answers. So you might say, here's the user, and here's all the answers I want you to submit. Or get a team score, and here's the team I want you to get the score for. And again, this isolates us from change, because if something happens, like the way in which we go from one bit of the application to the other, it's just an update in the DSL layer that's required. And our tests are starting to look a bit more like this. We're assigning a user to a team. we're submitting their answers, we're getting the scores, and we're checking that those scores are correct. And if this is the kind of business question we're trying to answer, does our code do this, we can see much more clearly that that test is doing the right thing. I've highlighted elements of our test, and we can see it's much closer to the language of whatever business problem we're trying to solve. And in reality, we'll have lots of tests, and they'll all be reusing the various DSLs, and those will be reusing page objects. And what we've done is we've now kind of decoupled our tests from the software under test. And we're just applying the same kind of good practice we would do for like normal code to our test code, like single responsibility principle. For example, each thing has one reason to change. So if we change an ID on a form thing, on a form element, then we just need to go to the page object, and that's one place where we need to make that change. And everything else stays the same. So the only reason our tests will change is because the business requirement has changed. And of course, this was a long time ago when everything was interacting with HTML pages. Now, maybe we've got things working, where our software under test might be consuming elements of queues or other ways of interacting with it. So maybe our tests, some of the stuff they're talking to, we're interacting with forms on a page, but maybe other things it's got to push something onto a queue or something like that. So again, our tests largely don't care. We've just got these intermediate layers that sort this stuff out. So our moral of story one is that testing an application's business logic via the user interface is quite complicated and time-consuming, and it's quite a lot of effort. But if we introduce these layers between our tests and the software under test, it reduces the coupling and makes our tests a lot more resilient. So ultimately, our tests don't change unless our business requirements change. And not really relevant to you, but I don't really like doing this kind of stuff, and I haven't done it for ages now, and I don't really like it, but there we go. So remember, the aim of this talk was, if we can decouple our tests, we reduce our overall costs, and hopefully you can see that if we are going to test via the user interface, and you apply the things I've just talked about, we will be making our test suites, the cost and maintenance costs lower. Yeah, hopefully we see that. But there's still some nagging things. Well, what happens if we completely rewrite our web interface, maybe replace it with an app, or maybe we just completely rewrite it, or then we have it for a PWA instead, or an SPA, or something changes entirely. Suddenly, all our tests that we had written are no longer valid, and we have to throw them away, and we need to start again. And it did feel like this was a lot of effort. There had to be an easier way of doing these things. So this is where story 2 comes in. And my journey through testing continued. So I was quite happy that we started automating tests. It certainly made my life easier, but I thought there had to be a better way. Now, in reality, I learned this stuff on a separate project, but so I don't have to introduce a new project, we'll just pretend we extended the existing quiz application with the 2 extra things. And those 2 things are that when you sign up, you have to pay, and after you've completed your quiz, you get sent an email that tells you how your score is and how your team is doing. So our application looks a bit like this now. So we've got a big blob of software, big black box in the center. We've got our user interface, we've got a payment gateway, and we've got an email gateway. And I was reading around testing to see how can we make our lives easier, how can we make this testing easier? And the real answer is to architect your code better. And there's a couple of ways. There's layered architecture and hexagonal architecture. If you've never heard of those terms, I'd recommend reading up on them. They are talks and possibly conferences in their own right. But we'll look at it at a very high level. So imagine we've got all our business logic. That's in the center, the blue circle in the center. And that's our high-value business logic that determines what is different or specific about whatever business problem our application is trying to solve. Around that, we've got this thin layer, which I've called a service layer, and that's just the interface to our business logic. That all sits in whatever framework you want to use, and then you've got the outside world. And the rule is that something inner circle doesn't know about its outer circle. So the business logic has no knowledge of what framework it's sitting in, or even the fact it's a web application. So our service layer, maybe we have a really simple interface to it. Our answer submission service, and it just takes the user, the quiz ID, and a set of answers. And this is what we're now coupling our test to, or majority of our tests to. So we have made some sacrifices in terms of coupling. Now we are coupled to whatever programming language we've written our software in. But we've coupled ourselves to something that's a lot more stable. So this service layer is a lot more stable than our user interface. And there's still quite a lot of flexibility. What actually happens behind here, we don't really know or care about. It could be a CRUD application. It could be doing something more clever. I don't really care at this level of testing. So really now we're testing, instead of at the user interface, we're testing kind of integration level testing. But you might say, well, that's okay. If an inner circle can't know anything about an outer circle, how does the business logic do anything like send a email or make a payment? So the business logic is aware of the interface to, say, an email gateway or a payment gateway, but not the actual implementation. So our email gateway, a very simple interface, could be something like this. We just say, who's the email from, who's it to, what's the subject, what's the message. And the actual implementation, the business logic knows nothing about. So the actual implementation, these blocks, the adapters, and they kind of live sort of in the framework. They're nothing to do with the business logic. And you have something similar for the payment gateway. And this has other advantages as well. We can then make dummy test doubles for our gateways. So we could have an email gateway spy. So it has to implement the send email method. But instead of actually sending an email, maybe it just stores it in an array. And we also implement an extra method, which gives it a way for our tests to query what emails have been sent after our test is run. So testing is quite a bit easier as well. We could have a layer between the test and the software under test, but things are kind of both languages almost in the language of whatever business problem we're trying to solve. So a test might say, I want to submit user answers, and our service layer probably also has got some method on there, I want to submit the user answers. So it's a lot simpler than we had previously. And you might have the testers talking directly to the service layer of the software under test. And testing becomes easier as well. So what we can do is we can get rid of our payment gateways, the real implementations, and replace them with test doubles. And instead of having to interact with our business logic via controller, we can just interact directly with it. So we can get rid of all the things that are quite difficult to test, and we've got a nice simple test entry point, and we've got test doubles for any interaction between the business layer, like sending emails and stuff like that. And compare how much easier that will be for testing than what we had previously. If we didn't have this stuff, then somehow when we want to instigate something, instead of just talking directly to our business logic via service layer, we'd have to construct some HTTP requests and put it in through the controller. And we'd have all kinds of difficulties as to working out whether emails really had been sent and whether payments really had been made. So we can see that by doing this, it's a far simpler way of testing our business logic, which is where all the high-value testing is. We still need to test these other bits, but this is where majority of our testing should focus. So the big but is we have to basically write our code in this way. What if our code is just one big black box we know nothing about? Well, if we are in that situation, then what we need to do is slowly kind of pick out the code. So I'd kind of advocate, work out what external services you're trying to talk to, wrap them up into some common code with a nice clean interface. So for things like talking to payment gateways and email gateways. If this is a long-lasting bit of code, you'll have to do it anyway, because over time, payment gateways and email gateways change. So even though your software is still just wanting to make a payment or wanting to send an email. So you'd pull out that code, partition it into neat blocks, neat adapters, and then you'd be in a situation where you start pulling out any business logic from the controller, putting it into our business logic, and then here we are back at the architecture we want to be. The best thing is to write our code in this way in the first place, but if you haven't, you can slowly, progressively change your code until you've got something like this. And if originally you had tests where you're testing via the user interface, as you pull out bits of code, you can just change the adapter. So instead of talking, making HTTP requests, you can say, right now I'm going to go and talk directly to the service layer. So this is a lot easier way of testing our business logic. So I think testing at this level is really powerful. We still have to do most of our testing at lower levels. I know I'm not talking about unit testing today, but that's where the bulk of our testing really should be. But when we've got all our individual components working correctly and tested, we need to make sure we've connected them together correctly. And this is where the power of the integration tests lie. And I quite like this kind of testing. I find it very useful. So what happens to our tests that we did via the user interface? Well, if we've got quite a good level of testing at our integration level, then we're kind of changing what we're asking. Okay? Before, we were asking, is our code behaving correctly? And we're testing it via the user interface. Now, we're pretty sure our code is behaving correctly because we've tested it very thoroughly at the integration level. So the question we're really asking is, have we correctly wired our user interface to our business logic? So what we could do is we could look at all the tests we've got, look at all our integration tests we have, and we'll say, well, I'm just going to pick out a few of those, and those are going to be the ones that kind of touch all the points of the system, and therefore we're pretty confident that our integration test layer is correct, and then we just say, well, we just need to do a few tests now just to make sure that we've wired everything up correctly. So our test base has reduced quite a bit from the testing via the user interface. And also, the level we're kind of operating at is a lot more stable than our user interface. So the moral of our second story is testing an application's business logic via the integration layer is much easier than when we're testing via the user interface. Because our coupling, so we've introduced coupling between our software under test and the service layer, so we are coupled to whatever language you've chosen, but it is a lot more stable part of our system. We still need to do tests. We still need to test that our user interface is correctly wired up, but that test base is a lot smaller, so it's a lot less effort for us to do it. And where possible, we need to write our code in such a way that makes it easy for this kind of testing to be done. Not only does it make it easy for testing, but also if we need to replace components like payment gateways and email gateways, it's much easier to do once our code is architected in the way I've just outlined. And again, not really relevant to you, but I much prefer doing this kind of testing. It's a lot easier. So remember our decoupled tests. The point of this was decoupling our tests reduces the overall cost of our test suite. And hopefully you can see from our second story that if we do the code how I've suggested and we do our testing at the integration level, it makes our test suite much cheaper and easier to understand and lower maintenance costs. Hopefully we're kind of in agreement with that as well. However, I was looking at things and I thought there's still elements of the test suite that seem to be quite tightly coupled to the software I'm testing. So there's still more that can be done. Still more that can be done. There's still bits that seem to be tightly coupled. So this comes on to my third story. And again, I'm kind of just making it up slightly. I was working on a different project, but to make it understandable to our quiz application, we're going to say it was such a successful project that we rolled it out to several teams. So now each user beforehand just belonged to this one company we've written it for, but now a user can belong to any company because multiple companies can use this. So you used to log in, you just have to say, this is my username and password. Now you have to say, this is my username and my password and the company I work for, because they all had different subdomains. So we're expanding stuff out to multiple companies. Yeah, so that's each company had a branded page in which they had their own subdomain. So when we're logging in, it's kind of all three things that are required. So I took my updated the code, took my existing test suites, and again we ran into problems where suddenly tests were failing. And we might be failing tests on things like this. Does an individual score get correctly allocated to their team? And that has nothing to do with this new functionality that we've added. So we've clearly got an issue here that we've changed code. Tests that don't care about what company a user belongs to are suddenly starting to fail. What have we done wrong? And it was down to how the data was seeded in the tests. So originally, I had some code, and what it did was it tightly coupled our tests to database implementation. So what would happen is we've created this extra field on a user, which is a company ID, because all users had to be associated with a company. But the way we created all our fixtures, all our test data, didn't cope for that. So I was using an application, I might well have written it myself, where you took a YAML data and it would look at it and say, fine, the kind of the top level thing here, the users, this is what I'm putting in the users table, these are the name of the fields that I'm populating the data in, and it would just create a load of SQL insert statements. And this I thought was quite clever and quite useful, but the problem comes is what happens when we change something like we add an additional field to the objects we want to put into the database. And it's fine if there's only 2 users, but in reality, there was a lot more. So having something that consumes the YAML file like this, creates insert statements, and puts them straight into the database is not ideal. I wouldn't recommend it, because we've coupled our tests quite tightly to the database, and database schema is implementation detail that really our tests shouldn't really care about at this level. And there's another reason why we might not want to put our data straight into a database in that way, is because we might have performance issues with some of our tests, and we say instead of using a real database, I'm going to use a fake database, or something that's a bit like a database but isn't. So I often use a repository pattern, and sometimes when I have lots of tests that hit something, I will write an in-memory version of the repository that just stores things in arrays. And you still need to you still need to test with a real database, but you can do a lot of your tests with in-memory variants, and it proves that everything works. So this is why we might not want to put data straight into our database. So if we're not going to create objects like that, how else can we create our data fixtures? Well, there's a number of options. We could hand build them, or we could use patterns like Object Mother or the Test Builder, which we'll have a look at. So we could just go and build things every time we need them. That's fine if we're only ever going to build a user object once, but in reality, we're going to build it many times. So it's a bit of a violation of don't repeat yourself. Of course, if an extra requirement comes in, like we need to associate a user with a company, we can go and update the code. But this isn't a great way of doing things hand-coded, because we'll need these users in many, many tests. So there is a pattern called the Object Mother, and it's kind of a bit like a factory. What it does is you just say, I've got an Object Mother for each type of thing you might want to build. So in this case, a user Object Mother, and you might have something like getAnna. And what that will do is that will create a user with all the default values. And if you use things like you have personas and you use user stories, then Object Mothers might produce, Anna might mean something in our user story. That might be a property about Anna. Maybe she's an admin user. Maybe Bob is a normal user, and Charlie is a different kind of user again. So the great thing about using this is Anna means something and Bob means something. It's specific to our user stories if you use personas in user stories. But even if you don't, everyone will eventually know this is what Anna means. She's this kind of user. And you might have a user object get Bob and a user object get Charlie. And the implementation is just building an object. It might say, have we already created one of these users? In which case, pass that back. Otherwise, we'll go and do whatever we have to do to create a user. And that means we've encapsulated the creation of the user. So if something comes along, like our extra requirement that we have to associate a user with a company, well, there's just one place we change that code. And all our other tests stay the same. So it's just a clever factory, really. Another way around this problem is to use something called a test builder. So we could get ourselves a user builder, and we could just call build, and it returns a user with a whole set of default values, but we know it's in a valid state. And with the build pattern, you could say, fine, I'm gonna use a builder, but I'm just going to override whatever bits that I want to. So I can say, well, instead of using whatever the default user is, I want this person to be called Annabelle, and I want her password to be password, and her team to be banana. And the key thing about both object mothers and builders is they're focused just on building one type of entity. And if they need to build something else, they can just defer off to other object mothers or other builders. So for example, we start off, we're just building, we're using a user object mother, and it's just building the user Anna. But when we add in the requirements for all users to have a company, we can just defer off how we build a company to a company object mother, and that will return something that we can then use to associate with Anna. So when we come back to this problem of how we get seeded data into our database, so we can still have YAML files which have a whole load of data which we want to put into the database, but rather than going directly into it, we can go via one of these kind of builder methods, and then this means that if something changes about how we create objects or how we create these entities, it's all encapsulated in one place, and all our tests won't suddenly start failing. So the moral of story 3 is when we're creating objects, use patterns like the object mother and the test builder. And as probably people are switching more and more to using immutable objects, the test builder even has application at unit test level. So let's say you had a user object, and you, at the time of construction, you pass in all the data required for it, and nothing's mutable. Then if later you come along and there is an extra requirement for a company to be part of a user, if it's all wrapped up in a builder, then that's fine, because every time you need a user, you'll just say, you use a user builder to construct you a user, and it doesn't matter to your tests that suddenly we have this extra field, because that's all stored in the user builder. So I found actually the builder pattern really useful even at unit test level. Most of the rest of the stuff is kind of integration level and above. And again, what we've done is we've kind of decoupled our tests from the software under test in the fact that how we create objects that we might be using for testing, you know, if something changes about that is all covered in our builder on object mother patterns. So again, this was the point of it. If we decouple our tests, we reduce the overall cost of our test suite. And hopefully you can see in that story how we've achieved those goals. So it's kind of a quick summary of the things we've seen. Story 1, we were testing via the user interface. Sometimes that's just what you have to do. But if we are going to go down that path, then we need to have extra layers in between our tests and our software under test to cope for changes, even tiny little things like, you know, an ID in a field has changed. From our second story, we looked at doing predominantly a lot of our testing at the integration level, and we see that if we architect our code in such a way that not only makes it easy for testing, it has lots of other benefits. It means our tests will be easy to run, they'll be a lot faster, and a lot easier to write. A lot less effort to do the bulk of our testing it here, rather than testing via the user interface. And the final story, we looked at how we build objects, and how it's often best to delegate those off to custom builders like Object Mother and test builders. So, although we focus quite a lot on the top of the test pyramid, and I haven't really talked about unit tests, I do think unit tests are essential. I do think they should be the bulk of the tests, but discussion about that is for a separate talk. So essentially, decoupling is good. because it reduces our development and maintenance costs. And we want to do it in our tests as well. We want to make sure that we're testing the right thing at the right level, so we're pushing our tests down as much as we possibly can through the test pyramid. And in order to have to make our lives easier testing, we need to architect our code well. So that's using things like hexagonal architecture and this layered approach. We want to do the bulk of our business logic tests at the service layer, so integration level and below. And we're just then testing the UI, when we're testing via the UI, that we've actually correctly connected it to our business logic. And finally, we want to think about building objects using the object mother and the builder patterns. So thanks very much for listening. I've been Dave Liddament. Thank you.